So let's talk about slant or oblique or tilted asymptotes for rational functions. First of all, when do we have slant asymptote? When we have a rational function, let me write this down. If we have a rational function such that the degree of the numerator is higher by 1 then we have slant asymptote. Example, say f of x equals x cubed plus 2x minus 1 divided by x squared plus 4x plus 1. So notice that the degree of the numerator is higher by only 1. So how do you find the equation of slant asymptote? We find the equation of the slant asymptote using long division. So notice that f of x, in order for f of x to have a slant asymptote, the degree of the top must be higher only by 1. If it's higher than 1, like let's say on the top you have x to the 4th and on the denominator you have x to the 2nd, then you do not have slant asymptote. Let's have a couple of examples. Find, well, let f of x equal x cubed plus 1 over x to the 2nd plus 2x. Find the slant asymptote. And I'm going to put in parentheses, if any. Well, this one does have slant asymptote. The degree of the numerator is higher by 1. So let me go ahead and go to the next page and perform the long division. So I do have x cubed plus 1 divided by x to the 2nd plus 2x. I want to perform the long division. I'm going to write that x cubed plus 0x squared, using it as a dummy variable, plus 0x plus 1 divided by x to the 2nd plus 2x. All right, so let's put an x in here. So x times x squared is x cubed. X times 2x is 2x squared plus 2x squared. So now I'm going to go ahead and subtract this. And what I'm going to get, x cubed minus x cubed is nothing. 0x squared minus 2x squared is minus 2x squared plus 0x plus 1. Okay. And now I'm going to put minus 2 here. Negative 2 times x squared is minus 2x squared. And negative 2 times 2x is minus 4x. And if I subtract this, I will get minus 2x squared, because negative times negative is positive, so they cancel. and negative times negative also is positive. So I'm left with 4x plus 1. So notice that the degree of this is now only, it's less than the divisor. So this is my remainder. So I can claim that, that f of x, that originally I had it as x cubed plus 1 over x to the second plus 2x equals x minus 2 plus the remainder, in this case, plus 4x plus 1 divided by x squared plus 2x. So what is the equation? Let me give myself room. What is the equation of the slant asymptote? So let me change color. The equation of the slant asymptote for f of x is y equals x minus 2. First of all, we all know that slant asymptote must be linear. Here's my x minus 2 that I got from here. So you are wondering, why am I ignoring the remainder? So what happens to this? Well, we ignore the remainder because as x is getting larger and larger and larger, this part is approaching 0. So it's not necessary for us to consider that at all. We must remember that to find the equation of slant asymptote, to do the long division, and then if there is remainder, you ignore that. Let's do another example. Suppose we want to find, suppose I have some g of x equals, say, 2x cubed plus 10x minus 1 over x plus 1. And find the slant asymptote, if any. And the answer to this one is there is no slant asymptote because the degree of the numerator is higher by 2. If I do a long division, if I divide the numerator and the denominator, I'm not going to get a linear function. I'm getting a quadratic function. X cubed divided by x is x squared. So in this case, no slant asymptote. The degree of numerator is higher by more than 1 degree. Okay, cool. Let's do another example. Suppose we want to find the equation of, let's say I have t as a function of x equals x squared over x minus 2. And find slant asymptote. Well, this one does have a slant asymptote because the degree of top is higher by 1. So let's do the long division. I have x squared divided by x minus 2. So if I put here x times x is x to the second, okay? And remember that here I should have put x squared plus 0x. X times x is x to the second, x times negative 2 is minus 2x. Okay, so if I subtract this, I get x squared minus x squared is nothing. Negative times negative 2x is positive 2x. And now the degree, so you cannot consider this as a remainder because the degree is 1 and you have a degree of 1 in here on the divisor. So I have to continue. So how about if I put plus 2? Well, 2 times x is 2x. 2 times negative 2 is negative 4. And if I subtract that, now I get 2x minus 2x is nothing, and negative times negative positive. So the remainder is 4. The remainder is 4, and we said that we ignore the remainder. So y equals, x plus 2 is the equation of the slant asymptote. Okay, let's do one more just for the sake of discussion. Suppose I want to do this. Let's do another easy one. How about some p of x equals x squared minus 2x minus 8 all over, okay, x. Well, let's see. Doing the long division, or in this case, it's really easy. I have x squared minus 2x minus 8 divided by x. So I do have, if I put x up here, x times x is x to the second. Subtract that, I get nothing. Then bring the negative 2x down, bring the negative 8 down. And then if I put minus 2, then I get minus 2x. Subtract this, and I'm left with negative 8. And we said we are going to ignore the remainder when we are finding the slant asymptote. So the equation of slant asymptote is y equals x minus 2 is the equation of our slant asymptote. Okay, I think you got the idea. I'll be talking to you soon. Thanks.